Hey everyone, welcome back to CodeReach. This is our third week of doing it online. Hope you guys are having a great day and a great week so far. First of all, if you guys have any questions about what we did last week or the week 2 weeks ago, remember that you can always contact me on Edmodo or during one of the question breaks. You can always ask a question in the YouTube chat. But this week we're going to be going through something that is really useful, and that is multi-threading. For most of the programs that you have written so far, you probably have noticed that all your code is executed in order. For example, I have this that just prints out welcome to CodeReach. You'd expect it to come out as welcome to CodeReach. And it does. You most likely want this behavior as it makes your code pretty easy to understand and debug. However, say you have some code that takes a long time to run, and you want to do something else while it's running. In a normal Python file, you can't do that because the code is running synchronously. This means that it can only do one thing at a time. What we want to do is get our code to run asynchronously, meaning that it can execute multiple statements at a time. Now you can use asynchronous code in your program to download files, perform giant calculations, or read and write large files in the background. Then your main thread can simply update when the operation is complete, instead of hanging while the task is running. Alright, so I have an example here. This is a Pygame program that all it does is it gets the universal time from a website using requests, as we learned last week, and it just draws it to the screen. So if we go ahead and run this, what we'll see here is that depending on how my internet goes, alright, see that just took a little, it's just waiting a bit, and it keeps going. It waits on that request to finish before drawing the player, right? We don't really want this. This is an example with async, where the time is fetched in the background and that's just updated when we get it. Now, of course, this also gives us the advantage that we don't need to get it every single frame, right? This API only updates once per minute. So why are we getting it, multiple times a minute when we can just time.sleep for 60 seconds and wait, right? So we're also saving resources by doing this asynchronously. So if we go ahead and run this now, we'll see that it runs at the normal time. But if we wait long enough, we'll see that the time will update. Alright, and as you can see, the time just updated, but our program is still running quite smoothly as it doesn't need to wait for the request to be made. The most basic way to make your code run asynchronously is to use the threading module. The threading module allows you to create threads which can execute code independently of your main thread, which is the thread that runs your whole program. To get started, import the threading module and create the thread. You'll also need to create a function that your thread will execute. Alright, so here, for example, I just have a little program here that just prints hello in a thread and prints bye in another thread. So if I go ahead and run this, as you can see, they're printing hello bye at the same time, instead of first printing hello and then printing bye. Now you'll find something strange here though. If I go ahead and press Ctrl C, the byes stop, but the hellos keep going. And that is because your Control-C is actually only being sent to the main thread, which is executing this code over here. It's not being sent to this thread over here, which is saying hello. To remedy this problem, what we can do is actually pass the daemon flag to the threading module. So what this does is it tells the thread to finish when the rest of the program finishes. So now, what technically should happen is that our program will stop when our program is terminated. However, this doesn't work in idle because in idle, your main thread actually never technically finishes. You'll notice that you can always execute statements as if it was still running in your program even after your program is done. So to do this demo, we're going to have to actually run this in the normal Python method, which is through the command prompt. Alright, so we're going to go ahead and just run this in Python. And as you can see here, now if I press Ctrl C, everything stops. Now that we know how to create a single thread, it's pretty simple to create multiple threads. What we can do is just create a list and store all the threading objects in that list so that we can access and manipulate them later. So if we go ahead and run this now, we'll see that we have 3 messages printing. Hello, hi, yo, hello, hi, yo. Alright. However, there is an easy way, and that is with a thread pool executor. So to get started with a thread pool executor, simply import concurrent.features, and then this is kind of the example code. Now note that with thread pool executors, you must pass a parameter to your function. With regular threading, you could just leave a blank tuple. However, this will not work here. It'll simply fail silently. So what we have here is the max worker. So this is the maximum number of threads. And then here is executor.map. So this is like a for loop. So for example, in range, right, we have a 0, 1, and 2. So for every single one of those items, it'll create a thread function and passes that item to the thread. Now, there is a way to do this without a with statement. However, the with statement is the most easy way, as it automatically has a join statement at the end and makes sure that you clean all your threads up properly. So what you'll notice here is that by and finish are printed at the end of all the execution. And that is because the with statement automatically has a join statement at the end. So this will automatically join your thread and clean everything up before continuing with your program. Hey guys, it's me from the future. I'm editing the video right now, and I realized that I completely forgot to tell you guys how to execute a statement before the join method is called with the with statement. So it's really easy. All you do is you just put the statement inside the with. All right. So this executor.map thing is the one actually creating the threads. Everything else inside the with statement is just regular code. All right. So hope that clears stuff up. Back to the lesson. So far in our lesson, our threads have kept mostly to themselves. They aren't interacting with anything else. However, in a real-world scenario, you most likely want your threads to interact with each other and the main thread. This poses a problem though. What if a thread tries to access something, and while it's accessing it, another thread deletes it? Or how about when a thread wants to increment a counter, but before it increments the value, but after it's gotten the old value to increment, another thread increments it as well? Well, so here's an example of what I'm talking about. So if we go and run this fake database program, we see here that we have two threads that are supposed to be incrementing it, so you expect the value to be 2 at the end. However, because this is a race condition, where the first thread gets the value, but before it's able to update the value, the second thread also grabs the same value, both threads are incrementing 0, right? So then after, the ending value is still 1. Now there are many ways to go about solving the issue. The first is to use a thread-safe data structure. This means that it is able to handle multiple threads changing and accessing data from it at the same time. An example of a thread-safe data structure is a queue. Now another way to solve this problem, which is what we're going to be doing, is using a lock. A lock is simply a way for threads to keep track of whether a resource is currently in use to prevent it from being modified concurrently. A thread that sees a resource that is locked will wait until it is unlocked before modifying it. So here's a database with a lock now. As you can see, if we run this, the ending value is 2. So what happens here is that we create a lock using threading.lock. Now whenever a thread calls the lock, it will be executing this code. So with self.lock is essentially calling something called lock.acquire. So lock.acquire waits until the thread is unlocked, and then once it's been unlocked, it will actually continue with the code. So as you can see, when it notices that the thread is unlocked, it will go ahead and lock the thread first to itself, and then execute the following code. Now at the end of the with statement, it will call lock.release, which will release the lock for other threads to use. Now you can do this manually simply by calling lock.acquire and then lock.release. However, it is better to use a with statement as it does this for you automatically. So to show you guys what I'm talking about, here I have a program where it's manually acquiring and releasing locks. So if we go ahead and accidentally acquire the lock twice, you'll see that the last statement actually never executes. That is because the thread is waiting for another thread to release the lock. However, that other thread, which is the same thread, is waiting to acquire a lock. So yeah, as you can see, it gets stuck in a dead loop. Now this is why you want to use a with statement, because with a with statement, it will automatically release the lock for you, so you never have to worry about this. Alright, so here's just a bit of bonus information, I guess. So if you guys read the lesson plan, you'll see that I have a tagline here, and it says CodeReach, right? So this is actually the program that generated that tagline. As you can see here, it's just a multi-threaded thing of the demo I showed you at the very beginning of the lesson. And this quite easily demonstrates how all the threads can be interrupted and executed out of order. Now, I want to clarify something for you. Now, we've been talking about how these threads are executing things at the same time. However, that's not really true. What happens is Python automatically notices when a thread is waiting for something. And if that thread is waiting for something, it lets another thread take over and execute its own code. Then, when it's finished, it will switch back to another thread. With the threading module, you are not actually truly executing your code at the same time. Python is just switching them out super quickly whenever there's a pause to let other threads execute work. Now, if you want to look into it more, there is the multiprocessing module that actually truly lets you execute code at the exact same time. However, that is completely outside of the scope of this course. I just wanted to get you guys familiar with the concept of multithreading and how to prevent race conditions in your code. A lot of these concepts that you're going to learn in threading will apply to multiprocessing as well. Alright guys, so that is the end of this lesson today. For your assignment this week, what I want you to do is, I told you guys to create a program that searches for movies last week. So what I want you guys to do is to put all of that requesting and getting information into a separate thread, then create a Pygame interface for your search engine. So for example, you might have a text box, and then after you'll draw, the movie covers or something, and then as the information becomes available from the API, you'll draw that dynamically to your Pygame application. So this is going to be a bit more of a challenging one. However, I know you guys can do it, and of course, if you ever need help, I'm here on Edmodo, as well as on YouTube as well. Alright guys, thank you for joining me today on this third week of CodeReach Online. I hope you guys will have a great week, and I will see you next week.